All right, we are going to continue on with our 1.3 notes. So the first thing we're going to look at is what we didn't quite get to yesterday, which would be our special solutions of linear equations. Okay, so if the variables cancel out, so both sides, they cancel out, the variable completely goes away, and you get the left side number equals the right. The answer is all real numbers. There is a symbol for that. If you don't want to write it out, you can put what we call a double barred R. So it looks like a capital R, but it's got an extra bar on the left side there. That symbol stands for all real numbers. If your variables cancel out and the left side does not equal the right, your answer is no solution. Not zero, no solution. 0 is a number, that's a solution. Okay, if you didn't quite get that down, we can come back to it later, but we got to get to the examples for right now. Let's look at these examples. So we should be copying down the original problems, and then we will start working through them much like we did some of our problems yesterday. All right, so yesterday we talked about when we have variables on both sides. What's the first thing we're supposed to check for? Distributive property. Can we distribute on this one? Yes. We sure can. On both sides, we can distribute. So when we distribute the 3, what do we get? Plus 6. The minus x stays the same. It was not in parentheses. It does not change. We can also distribute the 2 on the other side. Good. 2x plus 2. Now, if it helps, we can split the equation down the equal sign. After we distribute, what were we supposed to check for? Simplify. We simplify by combining like terms. Can we combine like terms on the left side?
No. Yeah.
Yes, we can. What can combine?
3x minus x.
Good. 3x. And the minus x, what would that combine to give me? 2x. The plus 6 stays the same. There was nothing to combine with it. Is there anything to combine on the right side? No, so it stays the same. Now, if I wanted all my variables together, it's usually the next step. So if I wanted to move this 2x over to the other side, what would I have to do? Good, we subtract it to get it to 0 out. But if I do it on one side, I better do it to the other side. What happens to my x's? Cancel out on both sides. They're totally canceled out on both sides. Good. So the whatever's left on the left side is just a 6 equals the only thing left on the right side is that 2. Does 6 equal 2? No, those do not equal each other, which means that there is
no solution.
Very good, no solution. So if your variable totally cancels out and what's left is not true, they don't equal each other, then there is no solution. All right, on number 12, again, we start our process over. First thing we should be looking to do is distribute. When I distribute this 2, what do I get?
6.
Good, 6y plus 10. The plus 9 stays the same. Then we also distribute the 6. We get, very good, 6y plus 18 plus 1. Again, that 1 on the end didn't change. Now we split it up. Can we simplify the left side?
Yes.
Well, yes, what can combine? 10 plus 9 is?
Hold on, bro. You can stop right there.
Good. I mean, I think we need to keep going. Equals, we combine on the other side. What do we get? We also get 6y plus 19.
That's a solution.
Now, we need to show that our variable went away. So what do we still need to do?
Minus 19. Minus 6.
Minus the 6y on both sides. I still want you to show that your variable's going away. They cancel out, and what are we left with?
19 equals 19.
Okay, now, if you get that far, you better not just leave it there. Don't box in 19 equals 19. It's a true statement. 19 does equal 19. So our answer would be
Solution.
no. All real numbers. All real numbers. If you don't like writing all three of those words out, you could use the double barred R instead. So you either need to write all real numbers or put the double barred R. If you just put a regular capital R, that's not the same thing. You're not getting points for that. If you want to use the symbol, it's got to be the right symbol. All right, so we're going to look at a few word problems before we get to our classwork worksheet for the day. Find a number whose product with 7 is the same as its sum with 18. So this is flashing back to when we had to translate. If we don't know what the number is, what should we use to represent it? A variable. What do you want to use? Annabelle? Say what? N. Okay. N works for our number. So we're going to say that N represents our number. The product with 7, how would we represent that? Liam? Product means what operation? Multiplication. So Janiyah? 7n. Product with 7 and the number would be 7n. Is the same as. What symbol in math means is the same as? Equals. It's sum with 18. So when it says it's referring back to that number. And sum means we are doing addition. So how would we write that? N plus 18. So we've got to be able to take these statements and turn them into equations. Usually you'll have is or is the same as to represent equals. Now this should be pretty straightforward to solve. Do we have any distributing? Combining like terms? No. So we can go straight to getting all of our variables together by subtracting n on both sides. What does that leave me with? 6n equals 18. Last step. N equals 3. Okay, so some of our word problems will just be translating what they tell us into an equation and solving it. All right. Let's give this one a try. The greater of two consecutive integers. Let's just stop right there. We're talking consecutive integers. If we're talking consecutive integers, we don't know what they are. We know we have 2 of them. What should we use to represent the first one?
C.
Sure, C. So C... C is going to be my smaller integer. If they're consecutive, they need to be related to each other. So if C is the first one, how would I get to the next one?
Big C.
We still have to use a C. But if my first integer was 1, what would the next one be?
C plus 2.
You're almost there. It's one of those.
C plus
If we're going one right after another. C plus 1.
Oh, I thought you said that one.
Okay, so if C is our smaller integer, the next one that comes after that is going to be C plus 1. That's our greater integer. For example, if our first integer was 1, the next one would be 2. 1 plus 1 is 2. Or if you started with 5, the next one would be 6. To get to the next consecutive integer, you've got to add 1. Do we have questions about those? Okay, we need those to keep going. The greater of two consecutive integers, so that's my C plus 1, is 22 more than twice the smaller. So whenever we see the word is, what symbol do you think we need to be thinking about? Equals. So the greater integer is 22 more than means we are doing what operation? Adding how much? Adding 22. So we're going to add 22 to twice the smaller. Twice means we're doing what? Multiplying by 2. So the smaller one was C, so we're going to take 2 times C. All right, so we got to be able to take these phrases and turn them into equations. Now, can we distribute anything?
No.
Combine like terms. Moving on to get our variables together. Which one do you want to move?
C.
How would you move it? Subtract C on both sides. That leaves me with 1 equals what?
20 plus 22.
C plus 22. My last step to solve.
Subtract 20.
Subtract 22. And what do I get for C?
Negative 21.
-21. But they don't just want C, they want the integers, both of them. So my other integer is going to be, careful, we got to take C plus 1. So that's -21 plus 1, which is -20. So those are my two integers, -21 and -20. A boat leaves New Orleans and travels upstream on the Mississippi River for 4 hours. The return trip only takes 2.8 hours because the boat travels 3 miles per hour faster downstream due to the current. How far does the boat travel upstream? Okay. So we need to know that when we are traveling upstream, how long did it take us? 4 hours. So our our time is 4 hours. Okay? Took us 4 hours. We don't really know anything else about when we were going upstream. So let's switch to downstream. Time downstream was 2.8 hours. Okay, what else do we know about it? Okay, we were going faster downstream. So if my rate here is R, and I don't know what it is, what would represent my rate going downstream? I'd take my rate and do what to it? If we're going 3 miles an hour faster, we would add 3 to it. R plus 3. Now, in order to do this, we need to know that our distance is equal to our rate times time. We have seen that before in some of our examples. Distance is always equal to rate times time. But if you don't know that, I'd write down that formula. Now, if we're going upstream and downstream, we're assuming that our distance is the same, right? We go up and then we come back. So if our distance is the same on both trips, then that means the rate for upstream times the time for upstream is equal to the rate times time for downstream. Here's what I'm saying. The distance up is equal to the distance down. So rate up times time up is equal to rate down times time down. If the distances are the same, the R times T's should be the same. I know that's a little weird to get used to. Okay, we're just using a plain old R for this one. So we have R times, what was our time? 4. Equals, then we go to the downstream ones. What did we use to represent our rate? R plus 3. It's getting multiplied by what number for time? 2.8. Okay, then we got to simplify this a little bit. So we take R times 4, that's just 4R. Something we haven't seen much lately is when we distribute from the back of our parentheses, but that's what we need to do. So we have 2.8R plus, we've got to take 2.8 times 3. 2.8 times 3, anyone? You're close. Two 2.8 times 3. Dominic?
It said 8.4.
It sure is. Okay, now we've got to solve this. What are we going to do to get all of our R's together?
Okay.
Subtract the 2.8R on both sides. Good, what does that give us?
1.2.
Good, 1.2R equals the 8.4. And then what's our last step? We have to divide. I'm running out of space, so I'll write it over here. The 1.2R equals 8.4. We divide by 1.2. And what do we get for R? Liam? 7. So that would be 7 miles per hour. That's what the units they were for it gave us. Now, what did they ask us? Because they didn't ask us for the rate. Liam, what'd they ask for?
How far the boat travels upstream?
Good. How far does it travel? So what do we need to do? Liam?
Multiply the rate by the hour.
Good. Multiply your rate times your time. So if it took us 4 hours and we went 7 miles per hour, how far did we go? 28 miles. So our distance was 28 miles. And we went the same distance going upstream or downstream. So we could have also plugged our R in here and multiplied those. 7 plus 3 is 10. 10 times 2.8 gives us 28 also. Okay, our distances were the same.